that you need to kind of be prepared for. We had one like this on our quiz, and what I'm going to tell you is when you try to determine similarity, if you have a triangle, you can do any of those three similarity theorems: angle, angle, side, or side, side, side. But if it's just a rectangle or any other figure, we don't have any theorems to use. So what we have to do here is we have to use scale factors. I already know all the angles are congruent. They're all 90-degree angles, right? And so it wants to know, are these two similar? So we're going to say, first of all angles are congruent. Okay, that's the first thing I'd start with. And we all have 90-degree angles, so that's pretty easy to identify. Okay, the sides have to be in the same ratio. Okay, so these are my two longer sides, these are my two shorter sides, or you could do length and length, width and width, or however you want to call them. But 25 over 15 and 15 over 9. Okay, now here's what I'm going to tell you. There's two things that we've done here to determine if they're similar, okay? And I know that cross multiplying is one of those two things, and that would get you to the point where, yes, they are similar, but they want to know what the scale factor is. And so the only way to get the scale factor is to reduce these two and show that it's the same value, okay? So if I reduced 25 over 15, 5 goes into both of them. And if I reduce 15 over 9, 3 goes into both of them. And so those are both equal, okay? So we would say, yes, this is similar. Sides are proportional. And my scale factor, we always use the letter K for the scale factor. If I happen to go the other direction, you could either say 5 over 3 or 3 over 5. I'm okay with either one. Okay. And that's what we would use for our scale factor. Okay, if I tried to prove that triangles are similar, we've got 3 ways to do that. Angle, angle, side, or side, side. Okay, one of those 3. And so on these 2 here, we have triangles. And so to prove if they are similar or not, okay, like on this one here, do I have any sides given to me? Are there any side lengths that we know? No, right? So immediately these 2 are out. I can't do either one of these because I need sides in order to prove sides are proportional. Okay? The only one I could use would be angle, angle. And I know the 90s degree is congruent, obviously. Okay? But if this is 40, what's L got to be? Or sorry, if this is 50, what's L got to be? Yeah, just gave it away, right? So L has to be 40. So I have 3 angles over here, 50, 40, and 90, and they do not match up with the 37 degrees. So I don't even really care what K is, right? And so here we would say, no, they are not similar, and we would simply say something like, the angles are not congruent. Okay, and that would be my explanation. Don't just say yes or no. Okay, tell me a little bit about why you think it's yes or no. If you would say yes, then you could say yes because of angle, angle, or yes because of whatever theorem that you're using. Okay, on these down here, we're just finding the missing value. The one thing that I would tell you on these is really be careful of the order that you put these in. Okay, like for instance on this one here, we got to pay attention to the markings of the angles, or just go small to small. But since I don't know what X is, it's kind of hard to determine what's the biggest and what's the smallest. So 1 to 2 markings, okay, is 9. Over here, between the 1 and 2 markings is 3. So I could do something like 9 matches with 3, because those are the two sides between the same two markings, okay? So something along those lines is what I'm looking for. You could reduce 9 over 3 if you want to, but you don't have to, okay? And it would be the same answer either way. And then I'm trying to find x. X is between the 2 and 3 angle markings. Over here, that would match with 15. But because I went from the big one to the small one, I got to stay in that same order. Order matters. We've said that over and over and over again. Order is extremely important. Once we have the proportion set up, this is the hard work right here. We've got to be really careful about how we set the proportions up. But I feel like once we get this set up, solving these proportions shouldn't be the hard part, hopefully. Because here, all I got to do is take 15 times 3 and divide it by 9. And if you want to do the work, if you want to say 9x equals 45 and then divide by 9, I'm okay with that. But I'm also okay if you just do 15 times 3 and divide by 9. Okay? Because some people would look at this and say, 9 is 3 times bigger than 3, so 15 divided by 3 would be 5. You could just look at the straight proportion, and you wouldn't even have to cross multiply. So a couple of different ways to get there, and so that's why you don't necessarily have to show your work there. But when you have ones like the x minus 1, remember on ones like that, you got to make sure you put them in parentheses, okay, and be able to do that. For this one down here, we have a 2x and we have a 6x plus 12, and it says find the value of x. So one like that, you don't have to do it twice. It's the same value of x. If I had like an x and a y, you would have to do a couple of different problems. But try to pick out the one that's the easiest to solve. You might have a couple of choices to use. All right, number 7. Okay, this is my tower, and then a nearby tree is also going to cast a shadow at the same time. Okay, label things here. The cell tower has a shadow that's 72 feet long. The tree is 27 feet tall, has a shadow that is 6 feet long. We're trying to find the height of the cell tower. Labeling and drawing a picture, I think, is really, really helpful here, okay? And so I would highly encourage you to do that. Trying to do it without the picture could be a little bit more difficult. On one like number 8, I would encourage you to do, change the units, because we have 5 feet 10 inches tall. Remember last week we said 5 feet 10 inches tall is not the same as like 5.10. 5 feet 10 inches tall, I got to do 5 times 12, which is 60, and then add 10 to that, which would be 70 inches tall. So you could change everything to inches if you wanted to, okay? And then do it that way. 12 inches in a foot. On number 9, find the length of AB. So I'm just going to simply put an X in right here. Because these two sides are parallel to one another, we're just going to set up a proportion, right?
For like the width bonus, would you like it? If we have to convert it to inches, would you rather have feet?
If we're talking about like the height of something, probably feet would be better, but I would probably take either one. Okay, unless it says to leave your answer in feet or inches, then I would probably take either one. There's a couple of different ways to do this one. But it's just another straight proportion, right? Lots of proportions on here. Setting a proportion, making sure the order is the same, cross-multiplying and solving. Same thing on like number 10. And this is the one I was talking about before. Make sure when you set this up, we're going to say 2x plus 4 is to 5, because they're on the same side as one another, as 3x plus 5 is to 7. On one like this, it's really important that you put parentheses around those expressions, because when I cross multiply here, I'm going to take 5 and I have to distribute it to the 3x plus 5. Okay? So you got to be really, really careful. Okay, number 11 is once again, it's the same question, but on this one, what you have to be careful of is 10 over 16 equals 20 over 28. And we're not solving for x here. We're trying to prove if those two sides are parallel. Are AB and CD parallel? In order for those to be parallel, you have two options here. You can reduce them both and say that they both have the same ratio. Or, what I think is even easier, you can just cross multiply. Okay? And if I cross multiply here, I get 320 equals 280. And that is definitely not equal. Okay? So here we would say that they are not parallel. Okay, so a lot of those are just setting up proportions, solving. Be careful on one like number 15. When I set up proportions here, and 14 is already kind of set up like we want it. But on number 15, I have to know what this little piece right here is. They're giving me the length of the whole bottom. This is 11, so what's the piece right next to it have to be? 18. I got to take the whole length minus 11, so this piece right here would be 18. Okay, and then I'm going to go 16.5 is to 11 as P is to 18. Those two sides that are split or cut are proportional to one another. So we got to find P. But the key here is don't put 29 in your proportion. Okay? You're using 29 to get the 18, but we're not putting 29 into the proportion. Okay, I'm going to kind of help you get this one set up. You are going to have one like this on the test tomorrow. We have two rectangles, a rectangular patio. Okay, so I'm going to go ahead and draw both of them. And it says it's going to be similar shape. Okay, and so the length of your backyard is 45 feet by 20 feet. The length of your patio, and just be careful here, the length of your patio is going to be 18 feet. And the reason I say be careful is because here it says the length is 45, so this is also my length, right? So make sure 45 and 18 are matching up with one another. Make sure you label your picture correctly. That's another reason why I think the picture is a big deal here. Okay, and we had one like this on our quiz, right? And I told you there's two ways to do this. And I don't necessarily care which way you do it, but the way I think is probably easier is just to set up a proportion. You don't necessarily have to find the width here. You can, and that's one way to do it, but I'm going to show you how you can do it without finding that length, okay? Or the width of that other rectangle. What is my similarity ratio? what two sides do we know both measurements to? Okay. So we're going to go 45 over 18. And if it was me, I probably would reduce it because those are fairly large numbers. 9 goes into both of them. So I could reduce that to be 5 over 2. Okay, this ratio is what we call our similarity ratio or the perimeter ratio. I can use it for side lengths or I can use it for perimeter. But that's all I can use it for, okay? But if I wanted to do it for perimeter, I can't find the perimeter of this guy, but I could find the perimeter of this. How do I find the perimeter of a rectangle? Add up all the sides, okay? So we know it's a rectangle, so I know that all the sides, opposite sides are congruent. So 45 plus 45 plus 20 plus 20 would give me a perimeter of 130. Okay, so then you could set up a ratio or proportion with 5 over 2 equals 130 over x. Okay, area is the one. And area was probably the one that was missed the most on the quiz. When you do area, you have to square your ratio. You can't use 5 over 2 for area. You can only use 5 over 2 for some sides or perimeter. So you got to make sure that you square that ratio. So my ratio would be 25 over 4. We don't know the area of either one. We're trying to find the area of the new patio. How do I find the area of a rectangle? Length times width. So 45 times 20 would be 900. 900 is the big one. We got to find the small one. Okay. So the key here is the ratio that I'm using in my proportion. If you use 5 over 2, you will get it wrong. Okay? And that's what a lot of people did on the quiz. They used 5 over 2 and did not square it. So, something you got to pay attention to and something you got to be careful of. They don't just come right out and give me the perimeter and area, but you should be able to do that pretty quickly. Perimeter is distance around, area is length times width. Okay, last page. (21) and 22. Once again, be careful here. You don't know any other side lengths, so this one you have to use the ratio, and don't forget to square the ratio. Okay, what we just talked about. So 21 and 22, you're using everything we just talked about. When you do geometric mean, this is what we talked about yesterday. You don't have to set up a proportion. On all three of these problems right here, we're going to leave it in simplest radical form. If you leave it as a decimal tomorrow on the test, you'll get counted off. Okay? So you have to know how to leave it in simplest radical form. I know it doesn't say that here, but that's what the exact value is talking about. So leave it in simplest radical form. Okay, on this one here. If you're trying to find or use the altitude, it's always going to be the altitude squared equals the two pieces that it separates, 5 and 8. So altitude squared, y squared equals 5 times 8. And then you'll have to simplify the radical. Okay. 25 would be the same way. On 26, That's kind of like the one we just did on our notes. That's why I added that note. I wanted to make sure you had that since I screwed that up yesterday. So go back and look at that one in your notes and use that to help you here. You have to find this first, but then you have to find the length of that whole thing. We want to find that, the whole height of that, but you got to find x first. Okay, on 27, what I would recommend on this one is you can draw the big one, okay, which is our original figure right here. We know all three sides, so that's the one I definitely want to use. And then I can either use the small one over here, or I can use the big one right here. Okay, so the big one, I'm going to go ahead and label it B, A, C. And then I'm going to use the medium-sized one, which is the one on the right. The 90-degree angle is D, B, C. BD is X. We don't know that. But we know that BC is 30. And now we should be able to set it up. Okay, you don't necessarily need all three sides here, but now we can set up a proportion. 34 matches with 30, 16 matches with X. Okay. If you did the small triangle, it would just be some different sides that you'd be using. Okay. And I think that's kind of the easiest way to go. If you want to draw the small one on there, you can do that too. But you don't necessarily need all three. You just need two of them because you're just trying to find X. Because we don't know each of these individual pieces, then we can't really use that formula that we did yesterday. And so that's why redrawing the picture would be a big deal there. Okay, I just wanted to kind of go through some different things, a lot of different things to kind of know, right? And lots of different things, but the biggest thing is